Now, for the next section, we're looking at 3.2. We're looking at maximum and minimum values within an interval. We've done all of this before. We've looked at graphs before. We've looked at graphs that have they have local minimum and maximum values and then absolute minimum and maximum values. And most of our functions, especially polynomial functions, won't have both an absolute max and an absolute minimum. But today we're going to be looking at how to identify the maximum and minimums within an interval. This is going to be the key here. Because, for example, this is a graph that's given. Most of the times when we looked at graphs, they continue onwards. There is no absolute max or minimum, or it can continue on and provide another maximum and another minimum. So what we're looking at today is how to find the maximum or minimum values within a specific interval. Okay, so in that case, when you're looking at specific intervals, this is a local maximum. This is a local minimum. We know how to find this. At the max, at the minimum, we know that the derivative would equal to 0. So to find this point, it should be straightforward. You find the derivative, set it equal to 0, and solve for x. But that's not the actual max or the minimum. This is a max. It is not the maximum. This is a local maximum, but the actual maximum value is here. This is the highest y value. And the actual minimum value is here. It is the lowest y value. That's what we're going to have to keep track of now. In this section, we're going to identify maximum and minimums on our graph, but we also have to keep in mind what the interval is that we're going to be working on, because those intervals may lead to points that are actually higher than our local maximums or lower than our local minimums. Let's take some examples and see how we apply some of these. Okay, so our first question, f at x is equal to negative 2x cubed plus 9x squared plus 4, but we want to find the max and min values from negative 1 till 5. So between negative 1 and 5, we want to identify what are our maximum and minimum values. The process will be very straightforward. We want to find the local max and local minimums. And what we know about them is that the derivative or the tangent, the slope of the tangent is going to be 0. So step 1, we find the derivative, which would be negative 6x squared plus 18x. Set that derivative equal to 0, negative 6x squared plus 18x, and solve. So we're going to factor out a negative 6x. We're left with x minus 3. And then we would solve for this expression and solve for that expression. So we have negative 6x equals to 0, which means x is 0. And we have x minus 3 is equal to 0, which means x is equal to 3. So we have our two values, which are going to be either the local max or the local minimum. We would still need to do some more work to figure out if these values are absolute max or absolute minimums. But now that we have local max, local minimum, what we need to check is to figure out what are the extreme values. To find the extreme values, we would need to find f of negative 1, because that's this point here. So if we plug in negative 1 into here, this would be negative 2 times negative 1 is positive 2, minus 9, so positive 2 plus 4 is 6, minus 9 is negative 3. Then we're going to take f at 0, right? X is 0. At 0, the point is 4. And then we're going to find f of 3. So 3 cubed is going to be 27, negative 54. This is going to be 81. 81 plus 4 is 85, minus 54 will be 31. And then we would find f at 5, and that's going to be negative 21. So based on these points, we can figure out that our absolute maximum, our extreme value, the highest point, is here. So there would be our absolute max. That's the maximum value on this interval. And f at 5, which is negative 21, would be the minimum. So that's the max, that's the min. Now again, if you were to graph this, we would see that f at 3 equals 31, this point would be an actual local maximum. It would be a curve. And this point would just be where the graph ends, where we stop measuring, where we stop drawing our actual function. Okay, let's take another example. So now we're looking at example 2 from the textbook. I'm just going to read it out here so we're all on the same page. The amount of current in amperes in an electrical system is given by the function that's written up here, where t is a time in seconds and t has to be between 0 and 5 seconds. Determine the times at which the current is at its maximum and minimum, and determine the amount of current in the system at these times. What this means is you want to find the max and the mins and then find out where are the max and mins and what are the max and mins. So in order to do this, we start with our process to find max and min, local max and local mins. To find where there is a turning point, we're going to be looking for where the derivative is 0, where the slope of the tangent is 0. Step 1, find the derivative. Negative 3t squared plus 2t, and I think I wrote this 21t, and then plus 21. Step 2, we want to set the derivative equal to 0. Negative 3t squared plus 2t plus 21. We are now going to factor this. When we factor it, I'm going to factor out the negative first, so 3t squared minus 2t minus 21. I'm going to cheat a little bit. See that it would factor into 3t plus 7 and t minus 3. Okay. And this would be our factored form, which means our t values are going to be t is equal to negative 7 over 3 and t is equal to 3. So our local max and local min are going to be at negative 7 over 3 and at 3. So at 3 seconds and at negative 7 over 3 seconds, which can be ignored because our time has to be between 0 and 5 seconds. So I don't need to know what's happening at negative 7 over 3 seconds. So we have now t equals 3 seconds, 0 seconds, and 5 seconds. We need to figure out where's the minimum and where's the maximum. So I'm going to find c at 0. So c at 0 would be 0, 0, 0 is going to be 0 amperes. We want to find c at 3. If we put c at 3 in, we will get 45. And then we want to check c at 5. We do c at 5, we're going to end up with 5. All I'm doing is I'm plugging 0 into here, plugging 3 into this equation, and plugging 5 into this equation. And that's how I'm getting the output, the amperes. Clearly, the lowest amperes, the lowest current output is going to be at 0 seconds, which has 0 amperes. The highest point is going to be at 3 seconds, which is going to be at 45 amperes. So therefore my minimum is at 0, 0. And my maximum is going to be at 345. Very straightforward. Understand the algorithm that we're going through here. In order to find the local max and local minimums, we're going to find the derivative and set it equal to 0. Doing this will help us identify where there are local max and mins. And in order to find the absolute max and minimums on this interval, we will take the local max and mins and also include the extreme values. The furthest to the left, the furthest to the right, meaning the boundaries of our interval. Once we determine the y values for all of these x values that we have put together, or the outputs for all the inputs that we put together, we just compare to see which one's the highest. The highest y value gives you the max. The lowest y value gives you the minimum. And it's going to be straightforward and simple as that.